Waiting for the computer to catch up. Okay. So when we are looking at a rational function, remember the definition is a polynomial in a numerator and a polynomial in the denominator. So what we're doing today is determining is what we're looking at, does it have an asymptote or does it have a point of discontinuity? Option 1, looking at no common factors gives us the conclusion that we have an asymptote. So when we are given a function, if the numerator and denominator do not have a common factor, then we know that there is a vertical asymptote at that point that makes the denominator 0. Essentially, if we have it in this standard form, where we can see all the different transformations, this letter H represents our horizontal asymptote. Okay? Or sorry, vertical. Vertical asymptotes are at the point H, and horizontal asymptotes are at the point K. So where X equals H and Y equals K. This is why yesterday's lesson was important. We should be able to take any rational function and put it into this form, because then right away looking at it, we know where our vertical and horizontal asymptotes are. So there's an example here in the box next to it. We have a function x plus 4 over x minus 3. We look at the numerator and the denominator. They are different. There is no common factors. By the way, if you do this, get out. We don't do this in math. If you have to delete something, it must be a factor, meaning either the whole thing has to be factored out, or there's like a common factor that you can pull out from both terms, and then you can factor that out. But if there are no factors, you can't just randomly go in there and start Xing stuff off. No. It's everything in the numerator must have a factor that is also present in everything in the denominator. Okay? All right. So we want this equation to look like y equals a over x minus h plus k. So my method that I showed you yesterday was to split the numerator. Okay, x minus 3 over x minus 3. I'm also going to do another little side note here. The reason I can do this is because if I have something like 1 over 4 plus 2 over 4, I can write this as 1 plus 2 over 4. This is like the fractions rules you guys learned years ago. Okay, if the denominator is the same, I can split the numerator as long as the denominator stays the same. Okay, all right, so I split the numerator. I want in this term to have a factor that cancels out with the denominator. I see that the denominator is x minus 3. I have an x. What I'm going to do is add a negative 3. However, I do not want to change the value of this equation. By putting a negative 3 there, I have changed the value. So to nullify it, I'm going to add a 3 here. So minus 3 plus 3 is a 0. So I haven't really changed anything. I've just changed the look of it. Okay, now I can jump down here. And they have simplified what I have up here. 4 plus 3 is 7. And I have an x minus 3 over x minus 3, 7 over x minus 3. So now you can see I have a whole factor in the top and a whole factor in the bottom. They are exactly the same. Now I can cancel them out. However, this is not 0, right? Any number divided by the same number is 1. So this simplifies to 1. This I cannot simplify any further, so this is my final equation right here. Now, if I compare it to my standard form, a over x minus h plus k, I can see that k is 1 and that we have a horizontal asymptote at y equals 1. And I can see that h equals 3, which means I have a vertical asymptote at positive 3. Okay, so this is basically a review from yesterday's lesson. We did this yesterday. In today's lesson, we are going to have something that looks slightly different. This is what we call a point of discontinuity. And Miss Gordon, you know this, doesn't like to write stuff. So we're going to call it a POD, so I don't have to write that entire sentence. So if the numerator and the denominator have at least one common factor, then we have a point of discontinuity on the graph. In other words, there's a hole. So we're going to have some smooth curves, some smooth lines that we're going to draw, but there's going to be a hole in the line or the curve. Okay, so let's take a look at an example. Here is a rational expression already in factored form. You can see that there is an x plus 2 in the numerator and an x plus 2 in the denominator. This means I have a common factor. I could cancel those out. In fact, I'm going to, because that is going to give me a much simpler equation. All I have to work with now is y equals x minus 4, which is a line equation. Those are really easy for me to graph. However, in this line, there is a hole. And so, where is the point of discontinuity? If x plus 2 is 0, that means the x value of the hole is negative 2. In order to find what is the y value, I'm going to take that negative 2 and put it into my simplified equation. Very important that you put it in the simplified equation. You put it in the original, you're going to have a 0 in the denominator, and then wah, can't do anything, right? So this tells me that the y coordinate is negative 6. So this is where the hole is. I want you to imagine something with me. Let's draw a quick sketch. Ooh, that was hard to say. X minus 4 means I have a y-intercept at negative 4. What is my slope? 1 over 1, right? So I also have a hole at negative 2, negative 6. That means somewhere down here, there is a hole. We draw, PODs as an empty circle. Okay, so my line goes on and on and on forever, but there is a hole in the line at the point negative 2, negative 6. If I were to sketch my first example here, here's my x and y axis. We said we had a vertical asymptote at positive 3. There it is. And we had a horizontal asymptote at y equals positive 1. There it is. So asymptotes are lines that we cannot cross and we cannot touch. Holes are holes. So in this sketch, because my leading coefficient is positive, my graph will look like this. We cannot touch the pink lines. Here, my simplified equation is a line, but there's a hole in the middle. Okay, so in our last example, we're going to do both. Okay, so a POD is a factor you can cancel. An asymptote is a factor you cannot cancel. So here is my original equation. Y equals x plus 4, x plus 2 over x plus 2, x minus 1. I see a common factor, x plus 2, x plus 2. That means I have a hole at an x value of -2. There's some kind of a hole. Here is my simplified function now. In order to find the y value of this hole, I'm going to input -2 into my simplified form. Get -6 over -3, so this is +2. So the hole is at -2, +2. I also know that there is a factor in the denominator that I cannot factor out. So this represents essentially the h, right? X minus h. I know I have a non-permissible value. I'm going to write this in here. Non-permissible value. And from now on, we're going to call these NPV. Okay? What numbers x cannot equal? X cannot equal NPVs. So here we have two NPVs, -2, +1. One of them turned out to be a hole. The other one turns out to be an asymptote. At x equals 1, we have a vertical asymptote. And in the last bit, they tell you that you also have a horizontal asymptote at 1, but I want us to do this one together. Do the math behind it. So I'm going to take my simplified equation, y equals x minus 4 over x minus 1, split the denominator, or sorry, split the numerator. I want my first term to cancel. So this gives me 1 minus 5. Oops, this should have been a plus, sorry. Whatever I write in the first fraction, I got to do the opposite sign in the second fraction. So this is not 5, this is -3 over x minus 1. Or you can put the fraction in the front, -3 minus 1 plus 1. So here is your asymptote that we are missing, 1 and 1. Okay, so again, let's do a quick little sketch. What might this look like? First, I do my asymptotes. Horizontal asymptote at +1, vertical asymptote at +1, a hole at -2, 2. -2, +2. Here's the hole. Notice also that the leading coefficient is negative. So rather than the little C graphs being in quadrant 1 and 3, they are in quadrant 2 and 4. Okay, so this is the gist. That is basically the whole lesson, but I'll do two kind of slightly more complicated examples with you. Okay, but these are the key points. Okay, we are given this function. I know this is irrational because there's a polynomial in the numerator and in the denominator. I need to be able to factor it to see if I can cancel any common terms. So I need two numbers that will multiply to -4 and add to -3. I am factoring the numerator. What numbers would work? -4, +1. Okay, so my numerator is x minus 4, x plus 1 over x minus 4. Okay, my non-permissible values, I only have one. X cannot be positive 4. Now, because I have a common factor and can cancel this out, this tells me that the NPV is a point of discontinuity or a hole in the graph. So my new function simplifies to x plus 1. In order to find what is the y value of the point of discontinuity, we are going to put the x value of the POD into our equation. So y equals 4 plus 1 equals 5. So now my point of discontinuity is at 4, 5. Otherwise, I have a regular linear graph. Okay, so let's give it a sketch. POD at 4, 5. Simplified equation is x plus 1. Here's my y-axis. Here's my x-axis. Where is my hole? 4, 1. 1, 2, 3, 4. 1, 2, 3, 4, 5. mx plus b is what linear functions look like. So the 1 is my y-intercept. And my slope is 1. So this is what my function looks like. So a line that goes on and on forever, but has a hole at 4, 5. Any questions about this example? Okay. In our second example, we are comparing two functions, and notice that they are both exactly the same except for one little sign. I'm going to ask you to split your page here, and I want you to write f of x in factored form and g of x in factored form so we can compare them side by side. Take a moment to do that. Okay, can someone tell me the factors for f of x? Louder, please, sorry. 1 and 3, thank you. And what are the factors for g? -1, -3, perfect. Okay, take a look. I have a non-permissible value where x is -1, non-permissible value where x is -1. In the f function, I can cancel that common factor. So now the f function simplifies to x plus 3. What kind of a function is x plus 3? Linear. And what kind of NPV do I have? Asymptote or hole? It's a hole, yeah. So it's a point of discontinuity or a hole. Looking at the G equation, I do not have any common factors. So what kind of function do I have here? Or what kind of NPV do I have? I have an asymptote. What kind of function is this? Polynomial in the top and yes, it's a rational, right? Polynomial in the top and bottom, this is a rational function. Okay, Let's look at this. So both of them look very similar, but the graph is going to be very different, right? For f of x, we have x plus 3. So we know we have an intercept of 3. And we have a hole where x is -1. So let's quickly find what is the y value here. So if I do -1 plus 3, this gives me 2. So my POD is at -1, +2. Let's draw that on there. -1, +2. That is the hole. Slope is 1. So there we are. That is the picture for f of x. For g of x, this one is we cannot graph this one just by looking at it because it is a quadratic in the top. And we have only had practice graphing linear polynomials in the top and bottom. This one. So in this question, we can say we know where the vertical asymptote is. It's at x equals -1, so I can draw the asymptote, but I can't really draw any other key features. So I'm going to grab my calculator here to help me with the picture. So I'm just going to graph the original one, x squared minus 4x plus 3 divided by x plus 1. All right, so with the help of technology, there is the right side. Is it going to show us the left side? It is not. Okay, good enough for now. So the right side kind of looked like this. I could put x equals 0 to find my y-intercept as a key point. I could make y 0 and solve for x as another key point. It doesn't ask me to do that, so I'm not going to, but you could in order to draw a more accurate graph. All right. Concluding statement. Both f and g have a non-permissible value at x equals -1. Describe what happens as each function approaches the non-permissible value. This is where we're stepping into the territory of calculus. I'm going to show you some notations. Okay? Again, I'm going to split my page. I'm going to do f on one side, g on the other. So what we want to do is describe what happens to the function as we get closer and closer to the non-permissible value. And rather than writing that whole thing in as a sentence, there's a notation for it. We say the limit, shorten it to lim, as x approaches, so we just point the arrow and then we write the number of the point we're interested in. So as x approaches -1, that's what this little symbol is saying. We want to make an observation, what happens on the left side and what happens on the right side. When we're looking at the function on the left side, we use a little negative symbol in the exponent spot to identify that we're on the left side of f of x. So what this is saying is what is happening to the function when x gets close to -1, starting on the left. So what I'm going to do is I'm going to look at my picture, starting on the left. I'm going to pretend I'm walking on this line. What number am I approaching in terms of the y value as I get closer to the hole? I'm approaching the number 2. So that's my answer. The limit, as I approach -1 from the left side, I'm approaching the number 2. I'll post the last example on our Teams today.